Hello everyone, and welcome to this audio podcast. This audio podcast in as part of sort of a radio as part of a radio edition. As part of a radio edition, and where this audio podcast is part of the Erythropoiesis edition. This audio podcast as part of the Hurricane Plexar. This audio podcast is part of a a Labonix Vendip. This audio podcast as part of a Storm Robotics production. In this audio podcast, there will be a sort of an sort of underpinning in around in around transplantation, and and uh, and where and where and where and where in line in line with previous sort of previous previous the previous audio podcast in this series. We'll delve into the importance of some aspects in around in around immunohematology, in around immunohematology and immunogenetics. There will be some bases in around serology, some aspect of serology as well. So in around transplantation there. So by the end of 1995, over 250,000 recipients with end-stage renal disease (ESRD) were alive in the United States. The number of new patients or new recipients undergoing ESRD sort of regimen had continued to increase at a rate of around between 7% and 10% a year. Although not all ESRD recipients are or were eligible or are eligible for transplantation or solid organ transplantation in mid 1990 in around mid 90 sorry in around mid 90 in mid 1990 to mid 1990s to in around towards 2000, in the year 2000, where the new millennium and year 2000 nearly 37,000 nearly 37,000 recipients were registered for possible solid organ transplantation in around and specifically around renal transplantation. Over 54,000 are over 54,000 people sort of are on sort of on the total the waiting lists for organs, and where in line with in line with this particular data. Obviously, this data is or this sort of the epidemiology around this is sort of the early 2000 or mid up to mid 2000 mid 2000s mid 2000s so up to for example from 2000 up to 2000 from 2000 to 2003 or 2004. The waiting list the waiting list for solid organ transplantation prospectively has unfortunately increased. However, over 54,000 recipients or people have been on a total waiting list for all solid organ transplants. However, in 1996, only 11,099 renal transplants were performed, and primarily 3,389 from living donors. For all the various solid organ transplants, huge disparity remains between the number of recipients waiting for transplantation and availability of suitable organs. In 1997, there were 3,900 patients waiting for cardiac transplants or heart transplants, 2,700 for lung transplants, 2,700 for lung transplants, 235 for heart and lung, and 9,600 for a liver, and 92 for an intestinal transplant. In 1996, 2,340 are on the waiting list for a heart, 805 for a lung, 39 for heart and lung, and 4,000 for liver transplants. For liver transplants were 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 performed owing to an increased experience and advances in surgical procedures, tissue preservation, and post-transplantation care, including immunosuppression. The overall success rate of transplantation had been improving, had been or has and has been advancing. In 1988, the 1-year allograft survival prognosis using a cadaver grafts or allografts was 76%. But by 1995, the 1-year cadaver graft prognosis, allograft survival rose or increased from from 76% to in 19 from 1988 to 87% in 1995, and the results of around renal transplantation from living donors also improved from 89% in 1998 to 93% in 1995. With the increases in early allograft prognoses, more and more patients have been experiencing long-term success, and this trend is also true for other in around other solid organ transplants. At 1 year, 70% to 80% are still functioning or have still been functioning. So unlike other transplants, the kidneys in around renal transplantation, kidney has an ABO implied sugar antigens articulated on endothelial cells of the blood vessels. Thus, if the donor recipient has a different blood group, a complex blood groups, or a different different ABO blood grouping, serology from recipient, the antibodies will result in what is referred as a type 2 hypersensitivity reaction in renal allografts, thus causing elimination of transplant through cytotoxic T cells cytotoxic T cells, so CD8 specifically, CD8 T cells specifically in and from where the major histocompatibility complex is concerned. T helper cells on CD4 T cells aid in sort of the acknowledgement, if you like, of transplants. Thus binds to explicit areas of the major histocompatibility complex, or MHC complex. Allograft recipients must also have HLA through through a rejection of preceding allograft, and this applies to pediatric renal recipients, pediatric recipients or patients that have had had more than one allograft. Um, many other diseases that have a significant immunopathogenic element, a variety of renal illnesses also have associations with the MHC. And at the same time, the first of these had been highlighted or illustrated as having an association amongst the DR2 antiglomerular basement membrane disease. Subsequently, a number of different MHC alleles had been coupled with a variety of other renal diseases. Techniques, pathology investigations, pathology investigations for MHC typing and serology had been advancing rapidly from serological to molecular based modalities. The examinations are frequently had been evidenced as being costly and do not and at the same time do not have a place in routine clinical practice. In complement to the MHC, a number of other genetic indicators that may be linked with a variety of renal diseases are being explored, but these are also currently solely have been of research intrigue. The this includes for example, had included immunoglobulin receptor polymorphisms and variant of alpha-1 antitrypsin in systematic vasculitis, and the association between various allotypes of the immunoglobulin molecules and antiglomerular basement membrane and of antiglomerular basement membrane disease. Renal transplantation in context of generality of solid organ transplantation is now a sort of a sort of common surgical procedure over many established medical or clinical centers or clinical sites. All renal units have pediatric recipients and patients awaiting an appropriate transplant, solid organ transplant on donor. But unfortunately, there have not been enough donors to conserve the autoimmune disease, at least in part where for example, patients suffering with diseases with conditions such as systemic lupus erythematosus or SLE, and other sort of autoimmune based renal diseases. So this at the same time, this in part is because most renal kidneys are rejected because the immune mechanisms or mechanistics of the recipient or patient. At the same time, the medical terminology used amongst the renal specialty to explain types of transplants between individuals and species even are defined as the following. So autograft is identified as as a tissue grafted back onto the original donor. So, for example, skin grafting after burns or varicose ulcers. Isograft is identified as tissue grafted between individuals of identical genetic constitution. So, for example, syngenic individuals, for example, where kidney transplantation or renal transplantation between identical twins. Allografts is identified as tissue transplanted between members of the same species, but the genetic aspects are different. So, for example, in around renal transplantation, and that come in around renal transplants, and where kidneys that come from one human and donated to another with a distinct pattern of inheritance. Then there's xenografts. Xenografts sort of prospectively have been sort of piloted and tried and tested in where one individual sort of in sort of more recent times, for example, had received a allograft had received a an organ from an animal, and was transplanted into a human being. However, the definition or the basis is where xenografts is identified as a tissue grafted between different species, or xenogenic individuals. So, for example, from animal to human. And though this modality though at the same time, historically, whilst the modality had been rarely used in early investigations, in early investigations, uh, in early investigations, in early investigations, uh, researchers and investigators had transplanted sort of animal organs into humans. However, the the early investigations that had been implemented were sort of pilot or initial investigations to understand sort of sort of the genetic basis, and also in around the sort of primitive basis in around serology, cross matching, tissue typing, and in around the major histocompatibility complex, and human leukocyte antigen, human leukocyte antigen aspects. And so at the same time, again, xenographs, again, sort of more prospectively, apart from sort of one case which had been reported, where an organ was transplanted from an animal to a human. The modality is generally rarely implemented. In around pediatric renal medicine, and this has allowed, for example, specialists or nephrologists and immunologists to collaborate, and there is sort of progress or clear progress in the investigation in around solid organ transplantation, around renal or nephrology amongst pediatrics, amongst pediatric in amongst pediatric specialties and in around paediatric nephrology, to determine whether at the same time uh, at the same time as in part of this audio podcast series, and as part of the aims and objectives again, the aims and part of the hypothesis, part of the hypothesis, if you like, is to was to determine whether the development of immunosuppression therapy with reduced sort of effects or side effects can be established, including the toxicological profile, for example, in around the nephrotoxicity, in around the nephrotoxicity post transplantation in pediatrics, and where at the same time to establish or at least identify sort of where wherein around again the cross matching for pediatrics in pediatrics and those suffering with different forms of renal disease, for example, and allowing to thus also prompt sort of prognoses, sort of decent prognoses, decent sort of prognoses in around transplantation, and the important investigations for possible match include lymphocytotoxic test, a mixed lymphocytotoxic culture test, and both forms of tissue typing. A clone match cannot be established unless the pediatric recipient is a twin, where isografts have been evidenced. There is generally what's referred to as a full house, or complete human leukocyte antigen compatibility. Thus, isografts allow prognoses in around renal transplants. For example, beyond 2 decades, sort of 2 decades, sort of quite easily. Other donors such as live from living related and cadaveric recipients, where recipients receive donors from someone who is established as sort of brainstem dead, are also applicable. However, the MHC complex and HLA characteristics are not identical except in live donors, and where there is a greater match complex. Thus are a decent match only because these constituencies are similar. Cadaveric transplants historically have shown and have been evidence of showing have been evidence as having a greater risk of rejection, but can be decent if carefully chosen and are able to last post sort of post transplant post transplantation, or post sort of surgical procedures. And there are still a few differences. So, for example, a sibling to sibling donor where HLA human leukocyte antigen and complement is similar should have for example should have in around between seven or more years prognoses, at least in context of the literature, and with greater differences of MHC complex or MHC and HLA characteristics between pediatric patients or recipients, the chance or probability of a prolonged functioning renal allograft prognosis is generally is problematic. So rejection and there will be in this audio podcast series there will be a specific audio podcast in around aspects of rejection as well. But at the same time, to inform rejection of solid organ transplant occurs mainly through mainly through immunobiology and the cytotoxic cell T cell effects. Thus, nephrotoxicity causes more nephrotoxicity um, um, causes more challenges. T cytotoxic cells aid in the detection of antigens and destruction of allografts, and T helper cells aid in the appropriate recognition of complexes. Thus, generally, there will always be there always there has been sort of evidence that there is always some form of of challenge, some form of challenge. So live and cadaveric donors seem to be better grafts in recipients unless uh, uh, unless um, unless the pediatric recipient has a twin. At the same time, there has been some data from works in a publication that has highlighted that isograft has a very has a very sort of strong prognosis with 97% in around 97%, and then sibling to sibling donors are a prognosis of around 95%, and then parental donation in around a survival rate or a prognosis a survival rate or prognosis of 92%, providing good MHC sort of MHC sort of interplay. Um, and at the same time, there's works that informs in around HLA matched and where decent cadaveric donor a decent cadaveric donor gives in around 90% survival rate or prognosis. HLA mismatched gives in around 84% 84% survival rate or prognosis. So in published works from 1999, there is a sort of there is there is in published works from 1999 there also is a sort of a graphic in a particular publication that looks at and sort of depicts sort of a link between graft survival or allograft prognoses against the months post transplantation, and again in part of this audio podcast series there will be a link to the different sort of citations and works that listeners can identify relating or regarding works to this series. So that draws this audio podcast to a close. This audio podcast in the Erythropoiesis edition. This audio podcast as part of the Hurricane Plexar. This audio podcast as part of the Labonix Vendip. This audio podcast as part of a Storm Robotics production, and where this audio podcast provides provides hopefully a sort of a sort of a basis in around transplantation as a generic sort of as a generic sort of specialty. Thank you.